Bismillahirrahmanirrahim. Assalamu alaikum. Physio Made Easy is an online course that is delivered through pre-recorded online lectures and streaming videos for both the undergraduate and postgraduate students to learn, recognize, apply, and recall the basic physiological concepts that govern the integrated body functions. We have made these hard concepts easy to understand and have prepared lectures that fits the academic curriculum designed for the students of basic health sciences. In this course, the student will be introduced to the physiology of every organ system for an optimal understanding of the human physiological process. A set of standard examination MCQs with answers and explanation will be discussed in another series of these lectures, which will help the students in achieving higher grades in their exams. The first lecture of this series is Concept of Renal Clearance. The learning objectives of today's lectures are concept and definition of clearance, to know about metabolic clearance rate, general and renal clearance, how renal clearance is used to measure GFR, renal plasma flow, renal blood flow, to analyze the net tubular reabsorption and secretion. Now coming to the concept of clearance. Metabolic waste products, ingested substances, and excess salt and water are constantly being removed from the body by a number of means, including disposal in the urine, in the feces, biochemical transformation in the liver, and for volatile substances, exhalation. Clearance in a biomedical context has both a general meaning and a specific renal meaning. The general meaning is simply that a substance is removed from the plasma by any of the mechanisms mentioned previously. Its quantitative measure is called the metabolic clearance rate. Renal clearance, on the contrary, means that the substance is removed from the plasma and excreted in urine. As mentioned earlier, renal clearance is the volume of plasma that is completely cleared of a substance per unit time. Renal clearance can be used to determine the GFR, renal plasma flow, renal blood flow, and net tubular reabsorption and secretion. Mathematically, renal clearance can be calculated as urine flow rate into the concentration of substance in urine divided by concentration of substance in plasma. The measurement of GFR is ideally done by a substance which is neither secreted nor reabsorbed, and hence its filtered load is equal to its excreted load. Filtered load is equal to GFR into concentration of substance in plasma, and excreted load is equal to concentration of substance in urine into urine flow rate. From this, GFR can be calculated by multiplying urine flow rate into concentration of substance in urine divided by concentration of substance in plasma. Inulin is one of those substances which is used to estimate GFR, having the following characteristics. It is an exogenous molecule, freely filterable, neither reabsorbed nor secreted, uncharged, non-toxic small molecule. Here in this figure, a known amount of inulin is injected into a body. After some time, the concentration of inulin in the plasma and urine and volume of urine excreted are estimated. For example, the concentration of inulin in plasma is 1 mg per ml and concentration of inulin in urine is 125 mg per ml, while the volume of urine is 1 ml per minute. Hence, the GFR can be calculated by multiplying the concentration of inulin in urine into urine flow rate divided by concentration of inulin in the plasma, which is 125 ml per minute. The GFR can also be calculated by creatinine clearance. Creatinine is a byproduct of muscle metabolism and is cleared almost entirely by GFR. Being endogenous protein, it is widely used for assessment of GFR but is not an ideal marker because a very small amount is secreted by the renal tubules. Now coming to the measurement of renal plasma flow, the following points has to be considered. Not all the blood delivered to the glomeruli is filtered into the glomerular capsule. Most of the glomerular blood passes to the efferent arterioles. Only 20% of the plasma is filtered, while the unfiltered substances must be secreted into the tubules to be cleared by active transport, for example, para-aminohippuric acid. Filtration and secretion clear only molecules dissolved in the plasma. Para-aminohippuric acid is a substance used for the measurement of renal plasma flow because it is filtered and secreted but not reabsorbed. Here in this figure it is shown that if the concentration of para-aminohippuric acid in the plasma is 0.01 mg per ml and the concentration of para-aminohippuric acid in urine is 5.85 mg per ml while urine flow rate is 1 ml per minute, the renal plasma flow can be calculated from the given formula: concentration of urinary para-aminohippuric acid into urine flow rate divided by concentration of para-aminohippuric acid in the plasma, which turns out to be 650 ml per minute in this example. After finding out the renal plasma flow, here we now calculate how to find out the renal blood flow. As we all know that 45% of the blood is occupied by RBCs and 55% of the blood is plasma. Hence, the total renal blood flow can be calculated by dividing the plasma flow, which is pH clearance, divided by percentage of plasma in the blood. As the renal plasma flow is about 650 ml per minute, hence the total renal blood flow can be calculated as approximately 1182 ml per minute from the above equation. The last part of our lecture is analysis of tubular reabsorption and secretion from the renal clearance. If the excreted load is less than the filtered load, some amount must have reabsorbed. If the excreted load is greater than filtered load, some amount must have secreted in the tubular lumen. And if the excreted load is equal to the filtered load, there is neither reabsorption nor secretion. This brings us to the end of this lecture. I hope you have understood the basic concept of renal clearance and its role in the measurements of renal functions. Thank you.